All right, guys, in this segment, we'll be talking about the continuity error or the continuity correction. What is this and how to arrange this? And basically, why do we need it? Okay, now see, when you are moving from a binomial distribution with the parameters n and p to a normal distribution with the parameters, let me write this y, the normal distribution, this mu and variance. So one major difference between these two distributions is that this deals only with the discrete data, okay? And this only deals with the continuous data, okay? So and you see, here when you write like probability y is less than, let's say, 7, so there is no problem if you say less than 7 or less than or equal to 7, because it is a continuous data. But here if you say there's probability x is less than 7, and if you say probability x is less than or equal to 7, these are two different statements, because the discrete data, we can't have the things in decimals. So this x is less than 7 does not include 7, but here this 7 is included. So if I take the next slide, you see we can have um, such kind of questions in a binomial distribution. And since we are modeling our binomial distribution as a normal distribution, so how would we adjust that, how this would be adjusted into a normal distribution? For this purpose, I'll have to remind you guys about the situations when you had to have a histogram and you have the discrete data, okay? So now this 9 over here actually means this is between 8.5 and 9.5. This 10 is between 9.5 and 10.5. I'm sorry, this has to be 11 here, okay? And this 11 is going to be between 10.5 and 11.5. Since I'm going to talk about this 10, so this 10 is actually going to be represented by this bar over here. Okay, now this 10 is basically which was a part of a discrete data. Now this is going to become a member of a family. He's going to be married into a normal distribution. So he'll have to behave, he'll have to be continuous data. Okay, so this is going to be considered as between 9.5 and 10.5. So if we have probability x is equal to 10, so this is when you have x is a binomially distributed data with n and p, okay? So when this goes into the normal distribution here, where you have y being a normally distributed data with the mu and this variance, so this probability x equal to 10 would be written as probability y is between 9.5 and 10.5. This is called the continuity correction. So this, which was x equal to 10, now this would be between 9.5 and 10.5. You can put that equal to mark anywhere or maybe on both of with both of them. There is no problem with that. Okay. Now when it says x is less than 10, so less than 10, this 10 is not included. So when we say less than 10, so that means we're going to consider all this blue area over here, okay, before this 10 over here. So this less than 10 would mean here that this is going to be written as probability y is less than 9.5. You have to object, but wherever you think, yaar, why am I writing it like this? So I hope this makes
Sir, can it be equal to 9.5?
okay, no problem with that. This is the continuous data. We are not ever bothered by this equal mark here whenever we are dealing with the continuous data. Okay, now the next one is when it says it is less than or equal to 10. So this means now 10 is included here. So this means all this bar is going to be included here as well. So this is going to be before this 10.5. When you consider this bar, this rectangle as a part of all this, so this is going to be probability y is less than 10.5. And nevertheless, you can put the equal mark if you want here. Okay. Now when you go on to this greater than 10, more than 10, okay? So you see for the more than 10 part, so this rectangle, should I consider this red area over here when it says more than 10? So this should be this pink area over here for more than 10 only, okay? So this would be probability y is more than 10.5. So basically you have to decide if you have to consider this rectangle as a part of the required area or not. Now, when it says greater than or equal to, look at this. Now, there's an equal to mark here. So, and we're going to consider the, like, the area after this more than this 10. So now this rectangle is going to be a part of this brownish area here. So this is going to be probability y is greater than, y is going to be greater than 9.5. Okay, guys, greater than 9.5. Okay, now I'll have to draw this again for this part. Now this is your 10 here, this is your 11 here. Now this means from 9.5 to 10.5, and this is your 11.5 here, and this is the rectangle representing this, and the next one, let's say it's like this is representing your 11.5. Okay, now guys, it says between 10 and 11. Now both of them are not included into this region here. Now please tell me, how should I write this? Yeah, please, it's your turn to tell me. It should be between what? Yeah. Yes, hurry up. Hmm?
9.5 and 11.5.
It should be, uh, if it is between 10 and 11. 10 and 11. I think I should have a better example here. Let me keep this up to 12 because this is really confusing here. I need to take it up to 12 here, okay? And if it is 12 here, and this is going to be 12.5, yes, we need to have an example like this, okay? So now it says between 10 and 12. So how should we write this now? Hmm? I think this is clear to you now. So this should be between 10 is not included, okay? So 10 is ending here. 12 is not included. So 12 is starting from here. So basically, we're going to talk about this area when it says between 10 and 12. So this has to be between 10.5 and 11.5. We cannot step into the area of the 10. We cannot step into the area of the 12 because they are not included. These plots, we can't step into these plots here, okay? Now look at this one here when it says we have to, this is between 10 and 12. Now this 10 is included, but this 11, sorry, this 12 is not included. So this means we're going to start from here and will remain up to this over here, okay? Before the 12, including all of the 10. So this would be between 9.5 and 11.5. And when it says between 10 and 12, where 12 is included, so guys, we can't take this, we can't go into the tens area. So this would be all of this between 10 and 12, where 12 is included. So this should be between 10.5 and 12.5. Okay. And for the last one, this is both of them are included. So it means we are going to take all this area here. So this is going to be between 9.5 and 12.5. It's better to keep an equal mark, at least one equal mark here. So that is how you fix this continuity correction or the continuity error while going from the binomial distribution to the normal distribution. In the next segment, I'll be taking a full-fledged question where we'll know, I mean, we will be approximately approximating a binomial distribution into a normal distribution and finding the required probability.